Hello everyone. Today we're talking about a super material, carbon fiber. We see it everywhere, from supercars to high-tech sports gear. We know it's incredibly strong and lightweight. But what happens when you turn up the heat? How heat-resistant is it really? Let's find out. The first thing to understand is that carbon fiber is a composite. It's not just the black fibers. Those fibers are held together by a glue, usually a plastic resin like epoxy. This resin is the key to the whole heat resistance puzzle. The carbon fibers themselves are amazing. They can handle incredibly high temperatures, well over 2000 degrees Celsius or 3600 Fahrenheit. They won't melt, they'll just sublimate at extreme heat. But the resin is the weak link. For a standard carbon fiber part made with epoxy, the heat limit is much, much lower. We're talking about a temperature range of around 150 to 250 degrees Celsius, or roughly 300 to 500 degrees Fahrenheit. Once you go past that point, the epoxy resin starts to soften and break down. The part loses its stiffness and strength. It doesn't necessarily burst into flames, but it fails structurally, which can be just as bad. So, how do we make it better? The answer is to use a better resin. Engineers can use special high-temperature resins, like polyimides or phenolic resins. These can push the working temperature up significantly, sometimes to over 400 degrees Celsius. This is great for applications in engine bays or near hot components. But what if you need something that can handle truly insane temperatures? This is where a special material called a carbon-carbon composite comes in. To make this, you take a standard carbon fiber part and bake it in an oven without oxygen at extremely high temperatures. This process, called pyrolysis, burns away the original resin and leaves behind pure carbon. Now you have carbon fibers held in a matrix of pure carbon. This material is a beast. It can withstand temperatures exceeding 2000 degrees Celsius. This is the stuff they use for the brake discs on Formula One cars, which glow bright red during a race. It's also used for the nose cones and leading edges of spacecraft that have to survive the fiery heat of re-entry into Earth's atmosphere. So, the answer to how heat-resistant is carbon fiber is complicated. It completely depends on the resin, or matrix, holding it together. It can be moderately resistant or one of the most heat-resistant materials man has ever created. Thanks so much for watching. If you learned something new and enjoyed this breakdown, please consider giving this video a like and subscribing. Your support helps us create more videos just like this one. We'll see you in the next one.